Okay, last class we did discussed about this one, right? Test bench architecture, and then how what is the verification flow. All these things we have discussed. What is the verification plan, test bench architecture, and that from that what are the test bench components like driver, monitor, generator, and then transaction. After that we'll go for the test and environment, after the scoreboard, coverage, and then checkers, assertions, all these things, right? In that today we will discuss about functional coverage. What is this functional coverage? Actually what it is explains that, suppose simple example you are taking, you are considering in calculator. Okay, you are checking that is that calculator is working fine or not. Okay, so in that I am considering some test cases like addition. Okay, so addition is working or not, and then multiplication. Okay, and then division. After that some other subtraction. Okay, all these things I want to verify through my calculator. Suppose you have written two test cases. Okay, two test cases related to addition and then subtraction you have written, and then you are not verified this multiplication and division, right? Then these two test cases are passed. Okay, addition and subtraction, two test cases are passed. Okay, two tests are passed. Okay, two test cases are passed, but is that saying that your design is 100% verified? Am I clear what I'm explaining?
Yeah, sir.
So is that 100% verified? No, right? Just give me a minute. So is that your design is 100% verified? No, right? Because you have not verified this multiplication and division test cases. So then how you said that? So this coverage will tells you, so 100%, see your calculator is verified, so addition and subtraction only, and you have not verified multiplication and division. Okay, so then you can't say that your design is verified 100%. Okay, so only 50% verified. Okay, so 50% verified, and then remaining test cases you need to pass it. Okay, right? So then just simply what I'm telling, that coverage is a set of metrics. Okay, coverage is a set of metrics that used to measure that design has been exercised 100% or not. Okay, so your design is exercised or your design is verified 100% or not. So whatever the design we are considering, your design is verified. Okay, so verified 100% or not. Okay, that will tells you this coverage. How we can verify that? Through test bench, right? So we are passing the test cases through test bench. Okay, through test bench, whatever the tests we are writing, all the tests we are writing here, and then pass it to dut. Okay, so then your dut will be verifying that. Okay, your dut will be giving that outputs. Okay, so that outputs we need to measure, right? So that is the coverage metrics. Okay, so through test bench, our design, how much it is verified, okay, how much it is measured, or how many test cases are passed, that measurement gives you the coverage. Understood, right? Just simple example I'm saying here. Suppose I'm conducting 100 questions. Just give me a minute so people are joining. Okay, so then again, uh, I am taking another example for that coverage. Okay, what is a coverage? Suppose I want to conduct 100 questions in a test. Okay, then you answered only 40 questions. Then your exam is completed? No, right? So your exam is not completed yet. Then still you are writing the remaining questions, 60 questions. Okay, as of now 40 questions you have completed. That means 40% of your exam is completed, and then remaining 60% you need to complete it. So same thing happening in the chip verification. So same way we are writing thousands of test cases. In that, how do you know that, okay, whether the test is tested everything? So this coverage will tells you. I told you in the verification plan. Okay, so verification plan, what it tells, how many scenarios, what are the scenarios are there. Okay, so what are the scenarios are there, all the scenarios we are listing here, right? So in verification plans, what are the design metrics are there, all the design metrics we are listing here. Okay, from that we know, okay, these are verified, these are not verified, right? Same way in the real world, so suppose you are verifying a car. Okay, so in that these are the features. Okay, what are the features? Start engine, brake, okay, accelerator, and then reverse, left indicator, right indicator, horn, all these things you are verifying that. Suppose you have written only for engine start, you have written the test cases related to engine start or brake, accelerator, all these things, but you never check that some reverse gear is working or not, and then parking is working or not, and then cruise control is working or not. So for these you have not written. Then if we have some 10 scenarios are there and you have verified only 4 scenarios, then how much percentage you are getting? 40%, right? So out of 10 scenarios, suppose I am having 10 scenarios, and then you have verified only 30%. So 3 test scenarios, 10 by 3, right? Sorry, 3 by 10. So 3 by 10, that means 300 by 10. Okay, so that means 300 by 10 means only 30% you have verified. Remaining 70% you need to verify it. Okay, that tells you the coverage. Okay, so what is the coverage, what is the need of coverage? So it tells you how much, suppose in complex scenarios, in complex IPs or chips. Okay, so thousands of test cases are there. Okay, so in that some particular register is there. Okay, that register is verified or not. Okay, suppose some register is there. Okay, that register is capable to store some values, some okay, so it is the capable to store some 0 to 7, 7 down to 0. That means whatever this register is there, okay, this register is capable to store 256 values. 2 power 8 means 256 values, right? So then you have tested only 0 or 2, some 4, and then whatever the even values are there, all these values only you tested. Then remaining 1 comma, that means odd values 1, 5, 7, 9, these values are not tested. Okay, so then you need to ask yourself one question: is that verified all the scenarios? No, right? So that gives you the coverage measurement. Okay, so coverage is nothing but what type of scenarios you measured and what type of features you measured or not. Okay, that will tells you the coverage. Okay, so that is the coverage. In that we have, see, we have two types of coverages: code coverage and then functional coverage. Okay, so code coverage and functional coverage. What it tells you, the code coverage. Okay, code coverage means maximum related to your design. Okay, so your design, how much through the test bench, how much RTL part is executed. That measures that code coverage. Okay, so code coverage is related to RTL. Okay, it measures that RTL code is executed or not through test bench. Okay, so through test bench we are verifying that is this write is happens or read is happens. Okay, so this if condition is verified or not. Okay, so this else condition is verified or not, we need to check that. Clear? Code coverage which tells you how much design is exercised, how much design is verified. So that tells you the code coverage. Okay, so here we need to ask one question here. Did if is executed? Okay, so did else is executed? That means that tells you that code coverage or functional coverage. Okay, so was okay, so was every state is visited or every state is toggled? All these things we need to verify through the code coverage. Okay, so in this we have different types of coverages. So block coverage, expression coverage, FSM coverage, and toggle coverage. So code coverage types, that means block coverage. Block coverage, what it tells you? Am I getting you guys? All of you?
Yes, sir.
Okay, fine. So we will tell you that what it is block coverage, and then what is the use of block coverage, and then how what type of things are executed in the block coverage. Okay, so then see in this block coverage, just give me a minute. Hmm. Huh. So this block coverage, what it is tells you. Suppose if condition I'm taking, if enable pin is there. Okay, if enable and some data we are writing here. Okay, some data equal to 20, and else condition we are writing that another data, some data equal to data plus 1. Okay, so these two statements are covered or not, so it will tells you the block coverage. Okay, so suppose we are writing that enable equal to 1, okay, the data equal to 20, we are hard coded, and then we need to check that this if condition is verified or not. Okay, so that these two lines are verified. Okay, fine, then go for the another condition, else condition, these two lines are also verified, so then your block coverage is 100%. Okay, but we don't get the 100% right, because here if condition I'm writing, if write. Okay, if write is happening means the data will be stored into the memory. Okay, so memory we are giving some address. Okay, then we are giving that write enable equal to 1 or write equal to 1, this data is executed. That means these two lines only executed. 50% of the code coverage is covered related to the block. Okay, so whatever the block I am taking, that is 50% is covered. And then remaining thing, else condition. This else condition I am writing that, so data equal to memory of address. Okay, so mem of address means reading the data. Okay, so from that address we are reading the data. Then if you are giving that write equal to 0, that means it is doing the reading operation, then these two lines are covered. Okay, so then this 50% also covered. Okay, then total 100% we are verifying that. That tells you that code coverage, but I am telling you this code coverage never gets 100% because some scenarios may be not executed. Just give me a minute. So clear about that block coverage, right? So what is the block coverage? What are the things we are verifying that? Okay, so this is tells you that block coverage. So in this, how many branches are covered or how many lines are covered in this if else condition, this will tells you the block coverage. Okay, and then expression coverage. What is that expression coverage? Expression means, see, we are writing that some conditions like if a or b, or if a and b. Okay, this expression we are writing. Okay, so expression means some logical expressions or conditional expressions, all these things. Okay, so then, so here, how many combinations are verified here? Okay, so how many combinations are verified? That means and operation or or operation is there. So and operation or operation means a b, two inputs I am taking, a or b. Okay, in this a or b, 0 0 means 0, 0 1 means 1, 1 0 means 1, 1 1 means 1. Okay, so now here what it is tells you, different combinations are exercised or not. Okay, so that will tells you this expression coverage. Okay, so expression coverage, what are the different scenarios? See, in this AND operation we have four combinations. All these four combinations, or OR operation, we have all these four operations. Suppose you want to open a door. Okay, so the key password is related to AND operation. Then AND operation means we are taking these two conditions a and b, 0 0 0 1 and 1 0 and 1 1. Okay, a and b, you are verifying that this is 0 and this is also 0, this is also 0, and this is 1. Now if both are correct, that only opens the door, right? So then only we will open that door. Okay, if both are true, both the inputs are true, then we are opening the door. Then we need to check all these combinations. So all these combinations are verified or not. Okay, that will tells you this expression coverage. Okay, and then FSM coverage, that means finite state mission. This finite state mission, you know, right? Some conditions called in your state mission, S1 is that one state pattern detection, you know. Okay, S10, S101 and S1010. Okay, these are the states, and enum I am taking that S1, S10, S101, S1010, and then some handle states you are taking, state handle T. Okay, so these tests are covered or not. Okay, these states are moving or not. Okay, so it will tells you that state coverage, that means FSM will tells you that S1 is covered or not, S10 is covered or not, S101 is covered or not, S1010 is covered or not. Okay, all these states are covered or not, we need to check that. Okay, that means we need to check that that transition is happening or not, S1 and S10. So this state transition is happening or not. After that, S10 to S101. Okay, this transition is happening or not. And the next one, S101 to S1010. Okay, this transition is happening or not, we need to check that. Okay, so then all the transitions are covered, then there is no error condition in the state. So then your all the tests are covered. Suppose in your states some error state is also there, but that state is not covered. Okay, so error state is there, that state is not covered, state is not covered. Then is that verified 100%? No, right? So then some coverage hole is showing that. Okay, so that coverage hole you need to verify. Okay, coverage hole is there. Okay, so that you need to fix that. Okay, that will tells you that FSM coverage. In this FSM coverage, different states are moving or not, we are checking that. Okay, and then toggle coverage means, so 0 to 1 or 1 to 0. Okay, so that is the toggling. Suppose your clock is toggling, that means 0 to 1 is changing, and 1 to 0 is changing, and 0 to 1 is changing, and 1 to 0 is changing. Okay, this toggling is happening or not, we need to check that. Okay, so that means suppose you need to take a switch. Okay, the switch is on or off. Okay, on to off is transition is happening, or off to on the transition is happening or not. That will tells you that toggle coverage. Clear? Any doubt from this up to now? Now, this code coverage is related to our design side. Okay, how much design is exercised, it will tells you. And then functional coverage. Functional coverage, what it is tells you that is that your specification. So it is related to specification based verification. That means suppose you are taking some I2C or APB protocol. Okay, just give me a minute. Huh. So you are verifying some I2C protocol or APB protocol. In that, I need to check that so my read is happening or not, write is happening or not, and wait state is happening or not, and ready error response is happened or not, reset and burst disable. Okay, so all these things are verified or not. Okay, so functional coverage is purely related to the verification engineer, so is modeling that designs. Okay, whatever the function design functionality is there, in that design functionality, so what type of scenarios are there, all these scenarios we need to verify that. This is related to the specification based. The specification they are giving, that in that specification we need to check that is that reading is there or writing is there. So read is completed or writing is completed. All these things we need to check that. Okay, that is related to the functional coverage. Okay, functional coverage, see, did read is happens, did write is happens, did wait state is happened, did error is happens, or did reset is happens. All these things we need to check that. Okay, instead of did, this if statement is executed or not, is this statement is executed or not, so that will checks you that functional coverage. Okay, suppose in your scenarios we have 10 features are there. Okay, so 10 features are we are verifying that. In that, only 8 features you verified. That means actually in the specification 10 features are there, but you listed 8 features, and then 8 test cases you have written. Okay, all these test cases are completed. Okay, all the 8 test cases are passing, then your coverage is showing that 100%. Okay, your coverage is 100%, but I'm not verified this ninth and 10th features. Okay, so these 10th and 9th and 10th features are not verified, then still your coverage is 100%. That means functional coverage, whatever the features you verified, you mentioned. Okay, so that will gives you that 100% coverage, but you are not verified that full specification. Then it does not automatically means that every specification requirement is meted. Okay, so that will not tells you that every specification is meted or not. Okay, you need to check that your specification is covered all the scenarios or not. That will tells you the functional coverage. Okay, clear? Code coverage and functional coverage. So functional coverage, it will measures you that specification covers. Okay, so measure specification is covered or not. Okay, that will tells you that functional coverage. Suppose address is there, read is there, write is there, burst is there, reset is there. Okay, did we address that 0 is happened or not? Okay, because 0 to 255 is there. That means all combinations, all the values, we need to verify it. Okay, 0 to 255 values is related to the address. That address values we need to exercise it. Then only we'll say, okay, address is covered. Okay, clear? Any doubt in this?
No, sir.
Okay, so then just you need to take that. So some Netflix you are taking, imagine a Netflix. So the code coverage, did I open every page and movie page or settings and search profile, all these things? Okay, these are all related to some specification. Okay, design. Okay, that means each and every page we have covered or not in our movie. Okay, and each and every settings we have uh, setting up or not. Okay, and then search and you are seeing your profile. Okay, your profile is verified or not. All these things are related to the code coverage. And then functional coverage, did user actually search a movie? Okay, so play movie that under pause the movie or downloading the movie. Okay, so if we are searching the movie or play the movie or pause the movie and then download the movie, and how much rate you are giving, these all are verifying through this functional coverage. Okay, that tells you the functional coverage. Why both are needed? Suppose code coverage is 100%, but never tested invalid address, but still there is a bug. But your functional coverage is 100%, but dead code is not executed, still it is dangerous. Dead code is nothing but the whatever you are giving, that is not executed. Okay, so that is gives you the dead code. Okay, so suppose you are taking some other things. Okay, so dead code is nothing but, suppose you are giving some values but still it is not wake up. Okay, that gives you the dead code coverage. Okay, understood? Dead code means whatever the code is not executed in our RTL, that means uncovered code. That uncovered code is related to the dead code. Okay, or not reachable code. Not reachable code means, suppose you are giving some other different type of scenarios but still it is not getting, then there is a bug. Okay, we need to inform to the design team. Okay, so there is a dead code is there, still I am not getting that coverage. So then functional coverage, code coverage, assertions and scoreboard all together determines this your sign off. Okay, during sign off, all these things we need to check that. Clear? So then cover group, what is that cover group? Because we need to check that different coverages like address, different scenarios are there. Okay, so like read or write or read write and then reset, error, burst, all these things we are checking, right? So in that different coverages we need to write. That cover group is containing that all the features. Okay, whatever the features we are mentioning in our verification plan, all the features are there in your cover group. Okay, so cover group is nothing but it's a container. Okay, it stores all the coverage information. Okay, so whatever the coverage information you are checking that, so that coverage information will be finding here. Okay, that is the cover group. Okay, so what is the basic syntax for the cover group is, so cover group name, just cover group and name of the cover group name. Okay, and then some statements you need to write here. Okay, so what are the statements, you want to write it, you can write it, and then end group. Okay, this cover group instantiation, how we are instantiating, this is the cover group. Okay, my cover group name is CG. Okay, end group, the instantiation is CG because this is the cover group name, and then handle I need to consider that, like how we are taking the class and class name, right? Same way, cover group name, this cover group name, some handle we are writing like packet, some pkt we are writing, right? Pkt equal to new. Same way here also, cover group name, and then cover group handle. Okay, then object creation, that is the cover group syntax. Then what are the contains, what it contains in our cover group? Some cover points it also there. Cover group is also having that some cover points. Okay, so what it tells you the cover points? Cover points it will tells you what type of signals you are covering. Suppose I am writing my cover group. Okay, cover group name is CG. So inside that I need to write my cover point. So this is some cover point name. C1 is nothing but cover point name. Okay, this is your cover point name. This cover point, and then what is the cover point we are checking, that some address. Address is the one cover point. And then another cover point you are writing that C2. Okay, cover point, and data you are writing, this is another cover point. Okay, so and also cross coverage is there. What it is containing, that cross coverage, that means we need to write that cross. Okay, so cross coverage means we have multiple cover groups. Okay, two or more cover points. Okay, in that everything I need to check that. See, we are four members are there, then one two three four members are there. So then four groups are verified correctly or not, I need to check that, cross check it. That means one is checking with two and two is checking with one, and 1 is checking with 3 and 3 is checking with 1, and 1 is checking with 4 and 4 is checking with 1. Okay, in this way, so that means 1 comma 2, after that 2 comma 1. Okay, and then 1 comma 3 and 3 comma 1, 1 comma 4 and 4 comma 1. All these scenarios I want to cover, that gives you the cross coverage. Okay, cross coverage, the combination of cover points we are checking here. Okay, so cross, the what is the syntax here, cross, and then c1 comma c2, that means address is checking with data and data is checking with the address. Okay, and then some sampling events or checking points are there. Okay, what is this checking or sampling? Okay, checking or sampling means we need to check each and every sample. That means at the rate posedge clock we are giving. At the rate posedge clock we are giving means, that means every posedge clock we need to sample our data. Okay, sampling means we need to get that output. Every posedge clock, every clock we need to sample our data. Okay, we need to sample our data. So that is that checking or sampling event. That means every instance we need to sample our data. That is the at the rate posedge clock will tell you. Okay, so this is at the rate posedge clock. Then this is the basic cover group syntax. So in this cover group, what we are writing? Cover group, cover group name, and then you are sampling at every posedge clock, then at the rate posedge clock. Okay, at the rate posedge clock we are giving that, and then cover point name. So c1 is the cover point, and then we are writing that some cover point. This cover point will tells you that which feature you are verifying that, and then cover point address, and c2 another cover point data, and then cross coverage. Okay, cross coverage c1 comma c2. In this way we are writing this cover group. Okay, end group. This is the basic syntax for your cover group. Okay, so this is your instance. Okay, cover group instance. Cover group name is cg, right? Okay, cg is my cover group, and then we are writing that cov is the instance or some cover group instance. So in this way we are writing that instance and creating the memory. Okay, creating the object. This is the cover group instance. Okay, clear? Any doubt in this cover group and then cover point? How we are instantiating the cover group with the clocking event at the rate posedge clock, also we are writing that, and then that means every posedge clock I need to verify my I need to sample my data. Okay, so cross coverage, you know, right? Cross coverage, we need to verify that different scenarios are verified or not. It will tells you that cross coverage. Okay, so how we are verifying that cross coverage means different bins we need to check that. So I will tell you what are the bins and then how to verify the bins in your coverage. Okay, this is the different clocking events I told you now. So without clocking we need to sample that manually. So cover group dot, you are instantiated, right? cg is your cover group, and then cov is the instance, and then that instance we are creating that object. Okay, sampling the object. So we need to sample it. Okay, how we need to sample that? Instance dot sample. Okay, without clock we need to sample manually, cg dot cov dot sample. Or you are instantiating with the clock means, that means in your cover group you are writing the posedge clock means every posedge clock we are sampling that, then coverage is automatically samples at every clock edge. Okay, this will tells you that coverage sampling. So every clock edge, and then read variable is happening or not, reading the variable, storing the variable, and update the pin and update the percentage. Okay, based on that clock edge. Okay, whatever the clock edge we are taking, so based on the clock edge, every clock edge these are verifying. Okay, so this is the flow of coverage. What is my clock edge? Is that posedge or negative edge? Okay, it will check that. In that, reading the variables. Okay, I need to read my variables and store the variables in the in the bins. We need to store the variables and then update the bins and then update the percentage. Okay, in this way we are checking that your coverage is meeting with 100% or not. Okay, what are the arguments we are writing in our coverage? Okay, cover group. So cover group name cg. Inside that we are writing any arguments means that will tells you that arguments related to address or data. Okay, or some other clock, all these things we are writing that. So each slave has address. Instead of creating 4 cover groups, okay, we pass the variable. Okay, so here apb has 4 slaves. In each slave we are having different addresses. Okay, so I don't want to create different address cover groups. Okay, so instead of that I need to consider one argument. Inside that some range I will give you. So reference, okay, reference logic 7 down to 0 address. This reference will gives you that different slaves having different addresses. Am I clear? Okay, so then cover point address, inside that we are creating different address 1 address 2 address 3. See, in our class we are taking that some packet. Okay, so in shallow copy we are taking different handles like packet p1 comma p2 comma p3 and so on. So okay, so p1 equal to new I am creating, and then uh, p1 equal to p2, p2 equal to p1 equal to p3. In this way I am writing my um, object assignment. Same way here also I need to create that different addresses. Okay, so cg equal to cov1 and then new of address 1, and then cov2 new of address 2. That means coverage instance. Okay, coverage. So cg and then different instances I'm creating, that cov1 cov2 cov3 and then cov4. Okay, coverage 1 coverage 2 coverage 3 coverage 4. So this is related to cover group, and then different different cover points handling by the cover group. And we are also writing some manual instantiation. That means cov dot sample or cg dot sample we are writing, and then every posedge clock we are sampling the data. Okay, we are taking some posedge clock, means every posedge of the clock we are sampling the data. That will tells you this coverage. Okay, study this summary. So you know the coverage model, how to write that. Okay, this is one coverage model, cover group name at the rate posedge clock. Here I need to check that address, read, write, and wait state, error, and then reset. In my specification all these scenarios I am writing. Then in my cover point also, cover group also, I'm mentioning address, write, error, reset. And also you need to write that cp some wait state. Okay, and then cp cover point some another condition. What is that? Reset is there, error is there, read is there, and then reading is not there. Then read also we need to write that. Clear? So in this way the cover group we are modeling here. So I told you cover points. What is the use of cover points in our functional coverage? Okay, so what type of cover points we are writing, that will tells you here. Okay, suppose I am a school teacher, so I need to check that each and every student in your class or not. Okay, the attendance we are taking that. Okay, then in my class 50 students are there. I need to check that student 1 2 3 and so on. So every time, okay, every time the student enters into that, and then we need to check that. Okay, we need to click on that. Okay, this student is present, this student is present. Okay, based on that, how many students are present, how many students are absent. See, in our schools, and then we are taking some attendance, right? So 1 to 50 members are there. Okay, in that different names are there. Student 1, that means a is the student, b is the student, is present or not. Okay, tick mark it. So then we'll know, okay, these students are present and these students are absent. Same way this cover point is doing exactly. So this checklist exactly what a cover point does it. Okay, it keeps track whether every interesting value is occurred during the simulation or not. Okay, I told you that address is having 8-bit address. Okay, so 7 down to 0. That means 2 power 8. How many values it will generate? 256 values, right? All these 256 values covered or not? I need to check that. Okay. So this cover point will checks that each and every value is there or not. 0 is there, 1 is there, 2 is there, 4 is there, and so on, so up to 255 is also there. Okay, so it will check that this cover point. So just tell me what is a functional coverage in one answer. Functional coverage answers in one simple question like, did I verify everything that in my design is supported to do? That means the functional coverage will tells you all the features, all the scenarios and protocol operations, and all the corner cases are verified or not. We are checking here. Okay, functional coverage purely related to your specification. Okay, clear? Any doubt in this? Hmm. So then in your coverage goal, so what are the design? So you design something in that. So what type of values are there, what type of scenarios are there, so we have to test. Okay, so and then any other test cases are not tested, we need to check that. Okay, that will gives you the functional coverage. Suppose I'm giving you another example. Suppose I'm a teacher. Okay, so this teacher, I'm a teacher, I'm conducting, previously I told you na, so 0 to 100, 0 to 100 student marks. Okay, so in that, everyone marks is there or not. Okay, so that means I need to check each and every student's marks. In this way I will divide that. Okay, so 20 to 0 to 20 marks. Okay, so 0 to 100 marks is there in different students are there, student A, B, C, D. Okay, in this different students, I want to check that 0 to 20 marks are there or not, or 21 to 40 marks are there or not, and then 41 to 60 is there or not, and 61 to 80 is there or not. So during our college times, they are asking, okay, how many got that below 50? Okay, so below 50, who got that, and then above 50, who got that? Okay, so they will ask you, and then this cover point will tells you. Okay, so what is the cover point? Cover point will tells you that marks. Okay, so in this marks, in this cover point, some bins are there. Okay, bins are related to marks range. Okay, 0 to 20, 21 to 40, 41 to 60, and then this will tells you that marks range. Okay, that means you are taking one feature address that will write in your cover point. Okay, so this is my cover point address. Inside that, some bins you need to mention that. Bins brackets equal to some range. Okay, 0 to 20, this is one bin, and then 21 to 40, this is another bin. Okay, so in this way we need to check that. Okay, clear? Any doubt in this functional coverage? I will tell you in brief what is the cover point, so what is the uses of cover point, all these things. Hmm. Tell me, any doubt? Hello.
No, sir.
Okay. So what is a cover group? Cover group, I told you, cover group is a container that holds many cover points. Okay. So that is the like a project folder. In this project folder, student attendance sheet is there, employee attendance sheet is there, and visitor attendance sheet is there. All the things are storing in one place. That is the cover group. Okay. Similarly, same way in my cover group, address, data, and then write, reset, write enable, and then read enable, all these things are verified, all these things are holding in your cover group. Okay, that is the cover group. And what is that cover point? So cover point is a integral expression or some variables you are representing that defines you behavior. Okay, what type of behavior we are getting that. Okay, so that behavior, and then it will collect that coverage. Okay, so cover point is the um, values or expressions or integral values we are giving that, and it will tells you the behavior. Okay, so it will samples that behavior and gives you the coverage. That is the cover point. Simple way, cover point watches one variable like address you are watching, then all the possible scenarios are there or not, it will samples and it will record that. PowerPoint records which of these values are occurred. Okay, how many values are occurred, in each and every value is occurred or not, it will tells you that. That is the PowerPoint. Clear? In this basic syntax for the cover group, I told you already. Okay, so cover group name, and then cover point, some address you are writing, and then instantiation, cover group, and c1 is the instantiation, and then we are initializing the object. Okay, and we need to sample each and everything. At every passage of clock we have to sample that address. Okay, clock address is sampled and coverage is updated. This is the way we are writing that. Clear? So then next, in that bins we are writing, right? So here some why explicit bins, and then explicit bins syntax we are writing. So bins are nothing but values. Bins in functional coverage, so bins is that, so coverage bucket. Okay, bins means it will stores that some values, right? Okay, so in real life we are going to that some supermarket, right? So like we are carrying that trolley. Okay, in that each and every things we are storing, right? So what are the things we are taking, all these things are storing in that place. That is the bin. Okay, so see here 0 to 31 is the configuration register, and 30 to 127 is the status register, and then 128 to 255 is the memory register. Okay, so just whatever that my addresses are there, instead of that, so different address registers are there. That means 0 to 255. Instead of writing each and every value, okay, all the values at a time, then I am dividing my address register into different groups. Okay, individual groups I am writing that. So then configuration register is one group, status register is another group, and memory register is the another group. Okay, in this way I am creating. Clear? So then in this each and every value, so some range values we are writing. So all these range values are we are getting or not, it will tells you the cover point. Okay, so in this way this is my syntax for the cover point. Okay, So what it is writing here, cover point, address, cover point, what is the feature I am covering, address. Inside that, see, configuration registers we have written, right? So bins, the name of the bins, configuration registers, and range you need to mention that. Here, how many bins are created? 0 to 31. This is one bin. One bin is created. Okay. So because here there is no automatic bins are there. So what is this range? 0 to 31 is the one range. For that, one bin is created. And then status registers, bins status registers, this is also one bin, that means 32 to 127 is the one range, this is also one bin. Then they will ask you how many bins are created here. For this one bin, and this is also one bin, and this is also one bin. Okay, so this is explicit bins. Explicit bins means we are mentioning that automatically it is creating that. Okay, so in same way some automatic bins are also there. Okay, automatic bins, how we are representing that? So coverage, and then some option we are writing that, like this is all, this is explicit bins, and then automatic bins, how we are writing that? Bins, some configuration registers, here brackets we are writing, that means how many bins are there. So 0 to 31. Okay, 0 to 31 means 32 bins are there. Okay, so each and every time 32 bins will be created. Automatic bins, what are the possible values are there, all the possible scenarios we are creating that separate bins. Okay, so 0 to 255 is there, means 0 to 255 bins are creating. Bins are nothing but value storing. Okay, so this is implicit bins. Implicit bins and explicit bins. Implicit bins are also called as automatic bins. Okay, explicit bins means we are representing manually. Okay, explicit means bins are declaring explicitly. Okay, so here manually we are defining the bins, so we only creating we are the engineers, right? We only creating the bins. Okay, suppose you are creating the different bins. Okay, so whatever writing here, different bins I am writing explicit bins. See, so my module tb, and then clock address and toggling the clock, here I am writing my coverage, cover group name at the rate posedge clock, and then cp address, and then cover point I have written. This is my cover point name. Inside that bins I am writing that 0 to 31, 32 to 127. Here all the bins are there. Okay, 0 to 31. Here one bin is hitting means it will be satisfied. Okay, 0 to 31 means what are that 32 values are there. In that, address equal to 10 is there, means this bin is covered, and then address is 80 means this bin is covered, and then address equal to 150 means this bin is covered. Okay, in each and every time only one bin is hitting means, okay, it will be satisfied. Clear? Any doubt in this? So this is the implicit bins. Okay, sorry, explicit bins. And then implicit bins, see here I am writing that range. Okay, so the range, so simulator will create that how much range, how many bins are creating here. So this is one bin, and this is another bin, two bins are creating here. Okay, So in that two bins, what is the range of values is there? 2 to 9. That means 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8 comma 9 is that one value. Okay, so in this one bin, okay, how many values are there? 9 values are there. Okay, so then all the times all bins are created. Okay, then how many bins are there here? 0 to 2 to 9 and 11 is there, so 10 values are there. Then how many bins is creating here? Total 10 bins are creating. Okay, simulator will create that 2 and 3 4. See previous example, in this 0 to 31 one value is hitting means it will be satisfying. Okay, 0 to 31 any 10 or 11 or 30 or 1, any value, one value is hitted means it will be satisfied. But here not like that, all the values I need to hit. That means 2 I need to hit that, 3 I need to hit that, and 4 I need to hit that. Okay, all these bins are hitting here. Okay, clear? Any doubt in this? So implicit bins, those are automatic bins. Okay, automatic bins means, so and what are the values are there, so all the values we need to hit here. Okay, so here we are writing that 10 bins are creating, that means 2 to 9. So 1 2 3 4 5 6 7 8 9. Okay, total 9 bins are creating here. Okay, because 9 values are there, right? So 4 and 4 8, 8 plus 11 9. Okay, so then total 9 bins are created, all the 9 bins I need to hit here. And same example, another thing I am taking here, bins of 4 0 to 7 is there. Okay, b3 of 4. That means here how many bins are created? You said that 4 bins are created. Okay, 4 bins are created here. What is the range? b3 of 0 bin, and b3 of 1, b3 of 2, and b3 of 3. So in this way 4 bins are created, that but the range values is 0 to 7, 0 to 7, right? Then 0 comma 1 is one range, and 2 comma 3 is the another range, and then 4 comma 5 is the another range, and then 6 comma 7 is the another bin. Okay, so in these 4 bins these values are storing here. In bin 0, bin 4, b3 of 4 is creating, or b3 of 4 equal to what is the bins we are creating? 7 down to 0 to 7. Okay, in this b3 of 0 is related to, so b3 of 0 is 0 to 1 is storing, that means 0 comma 1, and b3 of 1 is storing that 2 to 3, and b3 of 2 is storing that 4 to 5. Okay, b3 of 3 is storing that 6 comma 7. So 4 bins are created, each bin 2 values are storing. Okay, so then 4 bins are covered here. Clear? Any doubt? Same way, data cover points. What is the data cover point I am writing here? See, bins of 4. Then only one bin is created, that is 4. Then 4 is covered means it will be satisfied. Am I clear? Any doubt? Suppose here also another thing, b3 of 3 I am creating. Inside that, so here I am writing some 0 comma 0 to 4 is the one range, and then another range, uh, 2 is 7 I am creating. Only two bins are creating here, this is bin 1 and this is bin 2. That means b3 of 0 is storing that 0 to 4 range. Okay, so 0 to 4 range, and b3 of 1 is storing that 7, and then b3 of 2 is storing that empty. Okay, here two values are there. Okay, two bins, bin 1 and bin 2, but I am created three bins. In that, one bin is storing that 0 to 4 range and another bin is storing that 7 value. Then third bin is not creating. Okay, third bin is empty. But in the previous example, what I am taking here, instead of writing the value inside the bracket, I am keeping this empty. Okay, so empty and 0 to 4, after that 7 I have written. Then how many values are there? All values we need to hit. Okay, those many bins are created. That means 0, 1, 2, 3, 4. Okay, how many values are there? 5 and then 7. Then total 6 values are there. Then 6 bins are created. Clear? Are you understood what I am saying here? Hmm. So different bins you understood, right? So first I have created normal bins. Okay, B1. This is my B1 bin. Okay, in this bins B1. Okay, so what I am writing that different values like 1 comma 4 comma 7 comma 8 comma, these values I am writing. In this, how many bins are created? They will ask you. Only one bin is created. One bin is created. Okay. So only one bin is created. In that, any one value is hitted, means 1 comma 4 comma 7 comma 8. In this four values, 4 is hitted. 4 is hitted means, okay, this B1 is covered. Okay, B1 is hitting. Any one value is hitted means, okay, no problem. And then if you are considering array of bins, like same way, another bins I am taking that. Okay, so then each and every bin is generated. Okay, each and every bin is generated and each and every value I need to hit that. So how I am creating that? Same way, bins B1, this is automatic bin, this is the way I am representing that. Inside that, some value ranges I am creating. Okay, so how I am creating the value ranges? Some 2 to 5. Okay, comma, and then 7 is there. Okay, same thing, 2 to 5 and 7 is there, and then I'm creating these bins here. Then here how many values are there, how many bins are created? So this is 2 to 5, 2 comma 5 comma, and then 6 comma, sorry, 2 comma 3 comma 4 comma 5 and then 7. How many bins, how many values are there? 5 values are there. Then 5 bins are created. Okay, 5 bins are created. I need to hit each and every value. This is the difference between the explicit bins and implicit bins. This is the explicit bins and this is the implicit bins. Implicit bins are nothing but automatic bins. Okay, so in another condition I have, what is the explanation I have done? Bins of B1 and then here 3 is created. Okay, so 3 is created means, so same 2 to 5 and then 7 I'm taking. Then bins of 0 equal to 2 to 5 I'm taking here. Okay, 2 to 5 range is one bin, and then b2 of 1, b1 of 1 is equals to 7 and b1 of 3 2 equal to empty. Okay, this is the range, this is the way we are creating that empty bins also. Okay, suppose you are writing 4 bins of some range like this. Okay, so b1 of 4 bins you are creating that. Inside that some range you are creating 0 to 7. Okay, in that four bins we need to create. That four bins, the range will be divided. Bins of 0 equal to 0 to 1 bin, and bins of 1 equal to 2 to 3 is the another bin, and bins of b1 of 2 equal to 4 to 5 is the another bin, b1 of 3 equal to 6 comma 7 is the another bin. Okay, so this is the way. For explicitly mention that, you are mentioning that explicitly, four bins, then in these four bins we are creating all the values. Okay, any doubt in this? Clear, right? You understood difference between the implicit bins and explicit bins. So same way, here I am writing this one. Okay, bins of empty brackets 1 comma 4 comma 7 comma 8. So then here one bin is hitted means it is satisfied, but here four bins I need to hit that. That means bins of b of 0 equal to 1 is created, b of 1 is equals to 4 is created, b1 of 2 is equals to 7 is created, b1 of b1 of 3 is equals to 8 is created. Four bins I need to hit that. Separate bins are created here. Okay, so these are the automatic bins and then explicit bins. So automatic bins tool is only creating the bins, and explicit bins we are creating manually. Clear? So this is already, cover group, multiple cover points, CP1, CP2, CP3. All the cover points we are writing that. Coverage database, address coverage, data coverage, enable coverage, all are independently we are writing here. Okay. So this is the sample flow. Clocking event. So clock event and then sample coverage, evaluate the cover points and hitting the bins, update the coverage. Okay, this is the basic flow. That means event at the rate posedge clock we are writing that, and then cover group we are writing that. Inside that cover point we are writing, inside the cover point bins are writing, then bins are hitting means we need to execute the coverage. Clear? And then see, clocking event I told you, na, at the rate posedge clock and everything. And then sampling group means we are writing different cover points like address and data, enable, all these things. And cover points checks the bins are sampled or not, and then hitting the bins. Matching bins are counting increment is means the coverage is updated, coverage value will be incremented. Okay, see this summary. So this is the cover group model, how we are writing this. Cover point address related p address we are writing that. Inside that configuration, status and memory. So just we are splitting this 00 to ff, we are splitting into different values. Okay, and then p write, for writing also, see how many bins are created here, only one bin. Here also one bin. Any doubt up to this, all guys? Okay.